So for the first problem, first thing you need to do is find the slope of each line. Okay, you're not on a coordinate plane, so I would use the slope formula. So for C and D, remember your slope formula is, y2 minus y1 over x2 minus x1. So if I plug that in, I have 1 minus 4 over 2 minus 4. I should see this work on your paper for your test tomorrow. Okay, you're not doing this in your head. That gives me negative 3 over negative 2. What is negative 3 over negative 2? Positive 3 over 2. So my slope for CD is 3/2. I'm going to do the same thing for DE. So 2 minus 1 over negative 3 minus 2, which gives me a 1 over negative 5. It doesn't matter where that negative is. I just put it right out front because the whole thing is negative. Okay, you don't necessarily need it to attach it to the 1 or to the 5 because that whole fraction is negative. Same thing for FE or EF. 5 minus 2 over negative 1 minus a negative 3 would be plus 3, which gives me 3 over 2. And then for FC, I have 5 minus 4 over negative 1 minus 4, giving me a 1 over negative 5, or negative 1/5. Are we okay with all of those slopes? Yeah? Awesome. Okay, so using the problem above, is CDEF a rectangle? Explain your reasoning. So before we do that, what are two things we have to show to prove that something's a rectangle? What's the first thing? Opposite sides are parallel, and the sides have to be perpendicular. Okay, so are opposite sides parallel? Yes, right? These both have the same slope, these both have the same slope. Then we have to prove that the consecutive sides, the sides next to each other, are perpendicular. Are these sides perpendicular? No. Not a rectangle. Okay, you didn't have to show anything else because it was already up above. Number 3, find the slope of the line given the following. So same thing as number 1. I would have 2 minus 3 over 1 minus a negative 5, which would be plus 5. So that means my slope is negative 1/6. Based on the slope of the line above, what would the slope of the line be that is perpendicular to it?
Is he here?
I have no idea. I don't know their names yet. So what would be the slope of the line if it's perpendicular to negative 1/6? So it would be a positive 6 over 1. Questions on 1 through 4? Okay. So far, so good? Number 5, a line A contains these points, line B contains those points. Are the lines parallel, perpendicular, or neither? So let's start with line A. So line A, again, you're using slope. So negative 5 minus 4 over 3 minus 8, which gives me a negative 9 over negative 5, or just 9/5. Remember, if you have two negatives, they equal a positive. For line B, you have 2 minus a negative 7, so it would be plus 7, over 6 minus 1, so 9 over 5. Are those slopes parallel, perpendicular, or neither? Parallel. Why are they parallel? Because the slopes are the same. Okay, you need to be very cautious. If this one was negative, what would the answer be? It would be neither. Because in order for it to be perpendicular, the fraction has to be flipped and one has to be positive and negative. Okay, so you need to remember those things. So parallel, the slopes are going to be the same. Perpendicular, opposite signs, and the fraction is flipped, and then neither would be obviously not perpendicular or parallel. Okay, so make sure you watch that. Find the distance between each pair of points. Write your answer in simplest radical form. So before I can find the distance, I need to know what these points are. So this one is at 4, -3. And this one is at -4, -1. Do we know the distance formula? So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So far you have two formulas you need to know. You need to know the slope formula and you need to know the distance formula. Okay? If I plug that in, I get 4 minus a -4, which would be plus 4 squared, plus -3 minus a -1, which is plus 1 squared. 4 plus 4 is 8. 8 squared is 64. -3 plus 1 is -2. -2 squared is 4. So you end up with the square root of 68. Is 68 a perfect square? No. So you're going to factor. What two numbers multiply to 68? 34 and 2. And then 34 breaks down to 17 and 2. You have a pair of 2's. So those 2's come out. The 17 stays inside. Remember, your pairs come out. What's left over stays inside. Same thing with number 7. So let's see, -3, -2, and 2, 2. If we plug it into the distance formula, we get 2 minus the -3, so 2 plus 3 squared, plus 2, and then minus that -2, so it would be plus 2 squared. 2 plus 3 is 5. 5 squared is 25. 2 plus 2 is 4. 4 squared is 16. 25 plus 16 is 41. Can I reduce 41? Nope. So your answer is going to stay just like that. Still good so far? Awesome. I know I'm going fast. If you need me to slow down, let me know. And again, this is recorded, so it will go on to School Loop if you need to rewatch it. Number 8, find the midpoint. Okay, here's another formula you need. What is the midpoint formula?
x1 plus x2 over 2 and y1.
Good. Okay, so you're adding the x's together and dividing by 2, and then you're adding the y's together and dividing by 2. So, -4 plus 4 divided by 2. -3 plus 10 divided by 2. -4 plus 4 is 0. 0 divided by 2? 0. -3 plus 10 is 7. And I'm just going to leave it 7/2. If you write 3.5, that's fine as well. Okay, but you can leave it as a fraction. The only time I would change it to a decimal, to be honest with you, is if you have to graph it. But it's not wrong if you do. Same thing with number 9. So -2 plus a -6 divided by 2. And 6 plus a -4 divided by 2. -2 plus a -6 is -8. -8 divided by 2, -4. 6 plus a -4 is 2. 2 divided by 2 is 1. Any questions on the front side? No? We're okay? Okay. Here's where I think we're going to probably mess up the most. So I'm going to try to slow this down a little bit because I want to make sure that you have all the information that you need, because I'm going to be just as picky as I was on the quiz. So prove or disprove each statement about the quadrilateral, determined by the points, and then graph. So I'm going to start by graphing, if I can see these numbers because they're small. Let's see. 4, Negative 4, 2, so that's point A. Negative 1, 4 is point B. 1, 1 is C. Negative 2, negative 1 is D. Okay. So here's my quadrilateral. So first thing I need to prove is whether or not it's a parallelogram. In order to prove it's a parallelogram, I need to show that what? Okay, I need to show opposite sides are parallel. So I need AB is parallel to DC, and I need AD is parallel to BC. You need to write this step. Okay. From here, you can count, or you can use the slope formula, whatever you prefer. I'm going to assume you already counted. What did you get for the slope of AB? Okay, so you go up 2 over 3. What about for DC? Same thing, up 2 over 3. Are AB and DC parallel? Yes. Okay. AD, how many did you go up? You went down 3, okay, and then right 2, so negative 3/2, or you went up 3 backwards 2. Same with BC. Okay, which means these are parallel. So I'm looking for both of these statements. I'm looking for slope, and then I'm looking for it is a parallelogram. Okay, you actually need to give me that statement so I know that you know what the slopes mean. Some of you on your quiz put it is a parallel. Okay, make sure you look at the directions. We're talking about a parallelogram, to use the proper terminology. What do I need to do to prove something as a rectangle? Don't just tell me what I need. What's the first thing I need? Opposite sides are parallel. You just proved that, right? What else do you need? All sides are perpendicular. So you need to know AB is perpendicular to BC. You need to know BC is perpendicular to DC. DC is perpendicular to AD. And AD is perpendicular to AB. You've already found the slopes for all the sides. So we're just going to plug it in. So 2/3, negative 3/2, and so on. Are each of these sides perpendicular to each other? Yes. One's positive, one's negative, and they're reciprocals of each other. So all of these are perpendicular. You already know it's a parallelogram, so is it a rectangle? Yes. Is a rectangle, and you should write that. Now part C is the part that people missed on their quiz because they didn't read the directions. There is a big difference between perpendicular and congruent. If it says perpendicular, you're talking about slope. If it asks you if the diagonals are congruent, what are you talking about? The distance, the length. Okay, so we want to know if the diagonals are perpendicular. What are my diagonals? AC and BD. So remember, your diagonals go through your figure. Okay, we need to determine if those diagonals are perpendicular. Again, you can count because it's on a graph, or you can use the slope formula. Did someone find the slope of AC? Negative 1/5? Everyone okay with that? What about for BD? Are these diagonals perpendicular? Okay. What am I doing? Diagonals perpendicular. Okay. Last thing is to prove that it's a square. Okay, so for a square, you need to know opposite sides are parallel. We did that. You need to know all angles are 90 degrees. We did that. What else do we need to know for a square? All the sides are the same length. They're all congruent. So we need to know that AB equals BC, which equals DC, which equals AD. We need to know all those side lengths are the same. And how do we find the length of a side? The distance formula. So let's start with AB. Okay, I'm going to use the points AB up here and plug it into the distance formula. -4 minus a -1 is +1 squared. And then 2 minus 4 squared. So -4 plus 1 is -3. -3 squared is 9. 2 minus 4 is -2. -2 squared is a +4, which gives me the square root of 13. Are we okay with that? Okay, I have to keep going. So now I'm going to find BC. So using B and C, if I plug everything in, I have 1 plus 1 squared plus 1 minus 4 squared. 1 plus 1 is 2. 2 squared is 4. 1 minus 4 is 3. -3. -3 squared is 9. I'm still getting the square root of 13. Remember that if at this point they were different, you could stop, but because they're the same, I have to keep going. So I also need to do DC. So this one would be -2 minus 1 squared plus -1 minus 1 squared, which is -3 squared is 9, -2 squared is 4. I'm still getting the square root of 13. Okay, you probably can see that the last one will also be the square root of 13. If you want full points, you need to show me that. So AD is our last one. I have to fit it down here. So -2 plus 4 squared and -1 plus did I use the right ones? AD -2 plus 4 squared, -1 plus 2. Oops, minus 2. Okay. -2 plus 4 is 2. 2 squared is 4. -1 minus 2 is -3. -3 squared is 9, which gives me the square root of 13. So I know both sides are opposite sides are parallel. I know all angles equal 90 degrees. And I've just shown that all sides are congruent, so it is a square. Why is it allowed to be a rectangle and a square? Anyone know?
Rectangle doesn't have all equal sides.
Okay, so so listen to the statement carefully. Is a rectangle a square?
No.
No. Is a square a rectangle?
Yes.
Yes. Okay, so just because it's a rectangle doesn't mean it's not allowed to be a square, because a square is still a rectangle. It holds the same properties. Questions on number 10? No? Oh, I'm making good time. Okay. Number 11. Prove or disprove. So same thing. Prove that it's a parallelogram. First, I probably should plot those points. So -1, 1, 3, -1, 2, -3, -2, -1. All right. So prove it's a parallelogram. So I need to know AB is parallel to DC, and I need to know AD is parallel to BC. When you counted slope, what did you get for AB? Negative 1 over 2. So I'm assuming that's what you got once you reduced. What'd you get for DC? Same slope? So those two sides are parallel. What'd you get for AD? And I'm assuming you got the same thing for BC. Okay, so it is a parallelogram. We need to show the diagonals are congruent. So here we are looking for their lengths. So my diagonals are AC and DB, and I want to show they're congruent. I want to show they're the same. So using the distance formula, AC, 2 minus a negative 1 is plus 1, and then negative 3 minus 1. So 2 plus 1 is 3. 3 squared is 9. Negative 3 minus 1 is negative 4. Negative 4 squared is 16. 9 plus 16. And what's the square root of 25?
5.
Okay, so the length of AC is 5.
If you don't like get the square root, leave it at radical 25
Yes, because you can simplify that. So if it's a perfect square, you need to actually simplify it. Because remember, if you have radical 25 and you break it down, so say you just weren't thinking and didn't see it was a perfect square, what does 25 break down to? 5 and 5, and you have that pair, which now comes out, there's nothing left over, so you don't have the radical anymore. Okay? And then we also need dB. Let's see. Negative 2 minus 3 squared plus negative 1 minus the negative 1, so plus 1 squared. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. Negative 1 plus 1 is 0. 0 squared is 0. Are these two diagonals congruent? Yep. So yes, they are congruent. Here we're proving the diagonals are perpendicular, so we're looking at slopes. So now we're looking as AC perpendicular to DB. Did someone find the slope of AC? 4 over 3. Someone else confirm that? It's a negative? It should be a negative, yeah. And what about DB? That one should... Negative what?
I got negative 3.
You got negative 3 over 5? You got 0 over 5? Do they both have... So that's just 0? Are those slopes the same? Or I'm sorry, are those slopes perpendicular? Nope. So the diagonals are not perpendicular. So for DB, if you look at it, you don't go up any, which is why we have 0, but we went backwards 5. It actually should be a negative. Doesn't really matter because you still get 0. Or you use the slope formula. Whatever one works best for you. Okay. Lastly, we need to prove that ABCD is a square. Okay, so we've already proved opposite sides are parallel. We need to prove that all the angles are 90 degrees and all the sides are congruent. Now I want you to look at this figure real quick. What can I start proving that should end my work pretty quickly instead of starting with all the angles being 90 degrees? The sides being congruent. Because if you look at it, do the sides look congruent? Not really. So let's start there, because if we can show two of those sides aren't congruent, we don't have to do anything else. If you start with all the angles being 90 degrees, you're probably going to get yes for that, which is fine. That's not hard, because you already have the slopes. And we can look at it. We know the opposite ones are going to be 90 degrees, right? You'd have to write that out. But let's show that AB, well, we need to show AB, BC, DC, and DA are equal. So let's start with AB. Okay, we're using the distance formula. So for AB, okay, so for AB, we have 3 minus negative 1, so plus 1 squared, and then negative 1 minus 1 squared. 3 plus 1 is 4. 4 squared is 16. Negative 1 minus 1 is negative 2. Negative 2 squared is 4, which gives me the square root of 20. Can I reduce that to 2 radical 5? Everyone okay with that? Okay, let's do BC. BC should be 2 minus 3 squared plus negative 3 plus 1 squared. 2 minus 3 is negative 1. Negative 1 squared is 1. Negative 3 plus 1 is negative 2. Negative 2 squared is 4. So I just get the square root of 5. Are AB and BC congruent? Nope. So I'm going to stop and I can say it's not a square. So think about what you actually need to prove. Okay? If you can look at it and disprove it right away, I'm okay with that. If you can't look at it and disprove it right away, you need to go through those steps. So remember, for a square, opposite sides need to be parallel, angles need to be 90 degrees, all sides need to be congruent. Anyone get 100%? Couple people? Were the mistakes that we made slight, and hopefully we'll get 100% tomorrow? Yeah? Okay.